topic is blood group prediction with fingerprint images using deep learning. These are the contents. First we have problem statement. Traditional blood group testing depends on invasive blood sampling, chemical reagents and laboratory expertise. This makes the process invasive, resource intensive and often available at critical conditions like accidents, emergency situations etc. With advancements in biometric imaging and machine learning, researchers have discovered that fingerprint patterns may carry subtle features linked to blood group characteristics. Despite this potential, there is no existing fast, reliable that can determine blood group from fingerprint images. Therefore, the problem is to design and evaluate a non-invasive, fast, cost-effective method to detect an individual's blood group by analyzing their fingerprint images and machine learning techniques. Next will be continued by. Now coming to the pseudocode of this project. Importing of the necessary libraries, that is importing of the OS which is related to the files and the folders, and the NumPy used for the numerical arrays, and the matplotlib for the graphs, and TensorFlow for the deep learning model. And here coming to the dataset path. Dataset path is stored in a drive, that is dataset blood group of the different blood groups, A positive and B negative, and the training path and the testing path, which is the trained dataset and the test dataset folder is saved separately. Now coming to the splitting of the dataset, that is 80% of a training and 20% of the training. Now coming to the categorizing the dataset path, training ratio is 0.8, and for categories in the dataset path, the train size is which is stored in the train images, and the test images is stored in the test folder, and the splitting of the dataset path is completed. And now coming to the pre-processing of the images, it is coming to the resizing of the image and converting the grayscaling and RGB channels, red, green and the blue. Now coming to the different classes of the labels, which is X label goes to the different blood groups and its labels. Further we continue. Next, loading data. Images from train folder and test folder are loaded. Each images are converted into pixels. Each images get labels into X. A positive labels. Num classes tell how many blood group categories are present, and class weight it under A imbalance data set. If some blood group have more images, some have few images. The model may bias class weight gives the importance to classes that have fewer. Example, say image size 96 into 103. 103 increases the images in 3 colors we having, right? And learning rate. Usually learning rate is 0.01. Every 5 blocks it becomes an off. As the model runs faster initially and slow down later for better accuracy, building and CNN model. Efficient data. Extract the features from fingerprint. Accuracy versus loss. Epochs, 5 epochs. Then model is evaluation.
What is the accuracy?
Accuracy versus loss.
What is that epoch? Epochs.
Iterations. It helps to overfitting, making prediction. Model predict the probability for each blood group. Printing the classification report. It helps our model for each types of blood groups. Confusion matrix. It shows it is very helpful to understand the model. here we have a data set which is already splitted by training. We have class mapping and class
From
weights.
where you took the data set? Calculate. What is the size of the data set? 6,000 images you have taken.
So coming to the model function, here we have the layer types, output shape and parameters. Here we have calculated
Just
the
go to the
epochs.
previous slide. So what does the parameter indicates here? For the input layer it is 0 and efficient net. It is lakhs. What it indicates here? So in the table you have put layer and output shape and parameter that is being taken over there. So for dropout 3 it is indicating 0 here. So what are those?
It is the parameters which we have used in the layer types.
Yeah, layers. How many layers?
Ma'am, here we have taken only like 6 layers. Ma'am, it is around 7 layers.
So this is the stages, right? So in the input layer, the parameter 0. I'm not getting what is it actually. Batch normalization 5120 you have taken.
Like the input layer, we have used that input layer 7. Ma'am. In that we have parameters as 0.
So what is the parameter here? What you have considered as a parameter? What is parameter?
Like weights,
Hmm.
mapping, biases that we have considered as parameters.
Okay. So for the input layer, 0 parameters has been. Functional.
After trading, after splitting, we'll get as parameters as 0. Ma'am. For efficient, we get 4 lakh per something.
Dropout. So what you are doing in that layer, in the dropout layer? What is normalization? Just tell me what you mean by normalization. What is mean by normalization?
Optimizing. Ma'am.
Optimizing. So how the image will be optimized?
Like preventing the overfitting, now, like removing the errors or missing values or like
Then next stage is dropout. So in dropout what happens?
it prevents overfitting. Dropout prevents overfitting.
Then
Ma'am, it predicts the blood group.
it predicts the blood group.
We have total parameters that is 4,64 and 939, and trainable parameters are around 4,20,000 and 356. Non-trainable parameters are around 44,000. We have calculated the epochs. It is like 50 epochs that we
Is
have
this your
calculated.
result?
No, ma'am, this is calculation of epochs. In epoch, we have calculated the accuracy and validation accuracy. Next, coming to the graph, we have accuracy graph and loss graph. Here in accuracy graph, we have trading accuracy and validation accuracy. In loss, we have trading loss and validation loss. So classification report, we have calculated precision, recall, F1 score and subcode. And we have calculated the average of all the parameters that we have collected. Here coming to the confusion matrix, here we have a y-axis as true label and x-axis as predicted label, which are divided as the blood group types according to the values.
Can you elaborate it once? Like here A plus row wise, column wise. Just what it indicates, that number you have shown, what it indicates.
Ma'am, here we have calculated the predicted label of all the bread types. No? Here we have calculated the two labels of all the bread types and its values. 105 is the highest.
So the example ತಗೊಂಡಿರಿ.
Ma'am, in predicted labels we have taken as A positive.
ಈಗ ನೀವು ಒಂದು fingerprint image you have taken and how do you predict it?
We have taken A positive and we have calculated all the predicted labels and all the true labels. And in that we'll find the most highest accuracy. Like here we have 130 and here we have 105 in A positive. So we'll calculate it as 105. Further we will convert the marks.
This is the final UI and functional labels. First we have home page. Here we can upload the fingerprint images. Next we have processing page where we upload the fingerprint of the images like one or more. After uploading, the processing will be taken place. Next, after the processing, in this page we will have the predicted blood group. In that page we have number of fingerprints and their predicted blood groups. In this O negative fingerprint blood group, the confidence level is 81.86. In the other fingerprint image, we have 84.17%. In A negative, the confidence level is 73.32%.
Okay, so better is B positive one.
E positive. Next we will continue.
Studies that fingerprint images can use to predict the person blood groups by applying the image classification and machine learning models. The studies knows that certain rich pattern in the fingerprint have a small but consistent variations linked different blood groups, and this approach provides a SVM and CNN and KNN by using models. This method is non-invasive and very fast and does not require any chemicals. Successfully classification these patterns through techniques cannot enter replace traditional lablator through the complete laboratory and fingerprint, and it is the real-time group and detection variable hospitals and regulators and field level health.
Okay, what are the limitations? Is this system has any limitation? ಅಡ್ವಾಂಟೇಜ್ ಕೇಳ್ತಾ ಇಲ್ಲ, ಲಿಮಿಟೇಷನ್ ಏನಾದರೂ ಇದೆಯಾ? What is the prediction accuracy of the blood group? Let it